Let's get started. So this is a presentation on COMAP by Jack Picciuto, who's the Director of Operations. And I'll let Jack take it away.
Great, thank you, Brian. And I just want to make sure, yes, I'm unmuted. So yeah, so my name is Jack Picciuto. I've known Brian for a while. And I've been working with COMAP sort of in the role of as a judge for the contest, and we'll talk about the contest here in a little bit, and all the other things that COMAP does. But I actually now work for COMAP at COMAP as the Director of Ops. And like I said, I'll talk to you about COMAP today, and as well as what we do, and some of the specific resources. I call out a few that deal with differential equations and so on. So here's our mission, and it really is focused around this math modeling, and we'll talk about that. And it sort of drives the materials and resources that we create, as well as the contests that kind of probably one of the biggest thing COMAP's known for these days are the contests that we run. And but it's all about, like I said, education and so on. And here are just some of the specifics about COMAP. So first of all, that's what COMAP stands for, not the most obvious acronym there, but the Consortium of Mathematics and its Applications. It was established back in 1980 by Saul Garfunkel, who is still there. Saul is he's retiring this year, and there actually is an active search going on for his replacement as the executive director. Brian did mention, we were chatting earlier, that he and Saul were born literally days apart and miles apart. I don't think they knew each other until probably much later in life, but they go back, their relationship goes back quite a ways. The actual headquarters is in Bedford, Mass. It's about a half hour north of Boston, where you may have picked up, I have been told a slight Boston accent. So I grew up around Boston, and my background worked quickly, along with judging for COMAP contests, was, and where I met Brian was teaching at West Point. So I'm a West Point graduate myself, and spent my 20 plus years either flying attack helicopters or teaching mathematics at West Point. Both exciting in their own ways. But that's sort of my background. And after I got out of the military, I was a systems engineering consultant down here. I live down in Northern Virginia now, outside of DC, for about 10, 12 years. And then now I work for COMAP. The primary focus, like we said, is math education, specifically modeling, the modeling aspects of it. And we're small, but not small. So what I mean there is, there's only a handful of employees, some part-time, some full-time employees. But we have in any given year, 400 to 500 1099s, consultants, or whatever you want to call them, that help us with the triage of the contests and the judging of the contests. Like full-time is really small, but it really is a large organization. And I'm guessing some even in this conference today have some, hopefully some awareness of COMAP, or maybe you participated either years ago as a student or maybe as an advisor. And I'll talk more about those opportunities as we go forward. So this is sort of some of what we do. The main bread and butter these days tend to be the math modeling contests, but it hasn't always been like that. In the beginning, it was much more using NSF and other grants to do research and to do projects, to write articles and so on, and various other things that the organization would get involved with. The contest was a small thing back then, and it grew out of primarily demand. It just kept, every year was getting bigger and bigger. And then also as it grew, we added other types of contests. Really not other types, for other age groups really of contests. We have a pretty large resource of math modeling modules, we call them, and that have been written by folks, over the decades, really, and other aids. There's some videos, and I'm gonna sort of admit here, I mean, some of them are pretty dated. I saw one the other day. It was a video about voting, mathematics behind voting, and things like that. And there was video in there from, I think, it looked like I saw either JFK or Eisenhower walking out of a voting booth, and so there's some old materials here. A lot of the mathematics are the same, but maybe we want to probably at least get some color in some of those older videos and so on. But that's sort of, there's lots of these modules. A lot of these, a lot of the material, well, I'm not gonna say a lot, some of the materials are behind a membership sort of paywall. Some of these memberships are free for educators and students. There are memberships also, and this really isn't a pitch about joining COMAP, but some of the things are behind various, like I said, membership walls. A lot of libraries have subscriptions, academic libraries, to some of the journals and the other things that we put out. So like the two main journals, that Consortium and UMAP. Consortium is sort of focused at the high school level, and UMAP is more the undergrad level journals, and I'll have a little more about those. And then we also, this mathmodels.org, with lots of old problems on there and things like that. In the past, we have published or help editors and publishers publish some mathematical texts. We've got, for all practical purposes, one of the more common ones. Every once in a while, some of those go through a new edition and so on, and maybe some of you are even involved with that. And then we have a relatively new thing called the SIM project, which is a certificate in modeling. So a couple of years back, Chris Ani and a few others thought about doing some sort of certification course or program to sort of codify some of this thing about being a modeler. And it kind of has two tracks. We'll get into that a little bit. That project's going a little slower maybe than we originally thought, but lots of things are like that. But it's still plugging along, and I'll fill you in on where we are with that one. So here's some of the materials that we have. In general, they all tend to be very multidisciplinary, academically rigorous. Fun's kind of important, especially with some of these models and examples, where we do have so much emphasis these days in the contest when we write these problems. We want them to be something that, an average student would be interested in working on for a couple days in a contest scenario, or just in general. It's not hard to make them fun. The topics are usually, we try to make those sort of compelling for students, and an interesting thing to look into and to model. And then there's all, like I said, all types of formats and that we have. We realize the world's going kind of away from print and more online, so lots of things are like that. We have some of the older things we have are on media that it's hard to find the media, the device that will play that media these days. So we're trying to transition those. At one time, we transitioned everyone to CDs, but it's hard to even get a CD-ROM player anymore. So now we have to go to other methods and get these things so they are available for folks who want to look at them. So like I said, there's just some of the things that we have over the years and various types. That the Consortium magazine itself and the UMAP journal, the way those work is when they first come out, they are free to the world. You can go online, you can see the web version of these, and those both exist in hard copy too, but you can see those online. The current versions of those, they come out anywhere from 2 to 4 times a year. And then to see archived versions, that's when it gets to that membership thing to see some of the older journals. But you can always see the current one for no, it's just free to everyone. So this is a little bit more about Consortiums. Has been around a while, focused on the high school level. Certainly one issue a year we will give a lot of play to the high school level contest. We'll talk about what we saw in the contest. Some of the, we'll give examples of student work from the contest, and as well as just, there could be a couple other articles, but it's definitely focused on the high school level of the contest. Oh, sorry. Let's see if I can get back here. So, and this happens to just be one article that one that was written specifically that touched on the differential equations. And I know a couple of these I'm even going to show you. I think at least 1 or 2 of them are actually written by Brian Winkle. I don't know if he remembers writing them, because I know he's written a lot of stuff in the last, I guess, several decades or whatever. But what I did have the folks at COMAP do is the 4 or 5 that I'm going to show you today that specifically talk about using differential equations in modeling and modules. Those have been pulled out, sort of out from behind. If you did have to, if they were behind the paywall, they're now out. So if anyone wanted to look at any of these, you can go into, and I'll give you the website address. It's just comap.com, and you can search in there for resources and see what's there. But the 5 or so that you're going to see today, and if you have any issues, let me know, but you'll be able to actually download if you want to look those over and so on. Okay, next is the UMAP journal. And, once again, this has also been around since the very beginning, probably one of the first things they did. And, it does mention the two of the undergrad competitions, modeling competitions that we have. So during those particular issues, that'll be the focus. Very similar to the high school version, where it'll talk about, this is what we saw, and here's some of the creative examples. We'll give actually some whole solutions from students, and they're pretty, if you've never seen any of these before, pretty impressive responses that these students will make over the, right now it's about a 4-day window. It's really incredible. Years ago when this started, there was no limit to number of pages, and we would easily get 60, 70, 80 page submissions, which is a heck of a lot to write up, never mind develop and write up over the course of just a 3-4 day contest. Nowadays, these are all limited to just 25 pages, all in, including table of contents, references, everything, just 25 pages, just to help scope down the students, as well as make triage and judging a little more tolerable. And here's just, like I said, here's a couple of examples that were in previous UMAP journals that related specifically to differential equations. So there's one about civic engagement, climate modeling, and teaching, and specifically teaching differential equations. So like I said, all these 4 and the previous one that you saw, if you ever want to look, these specific ones, they're behind the, they are not behind this membership subscription wall. And if you saw anything else, and if you just send me an email, I'm sure I could get you access or send you a copy of a specific article. So regardless whether you have a membership or not, you can see what we have. And like I said, some things, depending on, when they were written and so on, are behind this membership wall, some are not. So anyways, that's kind of what we have there. So hopefully if you see, like, it's really just to show you kind of some specific things. And there's, over the 40 plus years, there are lots of articles, there are lots of, and they all tend to be around this math modeling, but all kinds of ideas and things that you can maybe use in the classroom or whatever you'd like to do. So now I'm going to talk a little bit about the contests. So we do run these 4 contests that you see on the screen in front of you. I'll talk a little bit about all 4 of those, and specifically what they are, but they're all a similar concept. The students, they'll log in. Well, there's a registration, teams of anywhere from 3 to 4 students, depending on the contest. They have an advisor who literally is the person, although, that'll be, typically it's a faculty member, but it's someone who's going to advise them, meaning register them, maybe find some space for them to work, feed them some pizza, but not come in and help them. This isn't you're not tutoring, it's nothing like that. Really, that would be against the rules. It's really just to sort of help the team. Now, prior to the contest, certainly the advisor could encourage students to log in, see previous problems, previous solutions, things like that. And all the contests are open source. So when the contest window is open, students can go in and use any source they want. Part of their submission, though, is, they cite references and so on. And it's pretty interesting that I know in the beginning, Brian mentioned about ChatGPT. So we've actually had a few advisors writing, hey, what's the deal on ChatGPT and these types of things. And, although, it's growing in popularity, it's growing in, I would say, ability. And, ChatGPT has some advantages. I think most academic institutions, I'm not going to say struggling, but they probably want to know more about it. And we're not discouraging any tool. If someone wanted to use ChatGPT to get some ideas and things like that, and they would document that they use the tool, It's pretty unlikely you could say, hey, write a 25-page submission. Well, first of all, I'm sure ChatGPT would do it, but I think that would probably not make its way through. We have heard I've heard some things, and it's in the news, that mathematics is actually one of the places where it's not the best at. It's very good at summarizing and things like that. But I just want to, I mean, I'm actually interested. I don't know if I'll go to it live, but I'm curious to learn more about ChatGPT. But right now, it's just a tool. And if you use it, you document it and so on. Okay, so this is the middle school version. This one's only a couple of years old. We've only just had the second one. It's a 13-day window. Now, we're not expecting middle school students to sit in a room for 13 days and work on the problem. We made the window wide so they can go in over that time, find a couple of days. It's really supposed to be like a day or two is really what the expectation. They can work on it for all, 13 days, but that's not the intent. A couple of photos there. The first one we did on the left was about a dog park, designing a dog park in your hometown and things like that, what you would have to do. And the second one that we just ran was about you're going to a carnival or amusement park, and there's some things you want to do, and there's different timelines and certain shows you want to see, and sort of how would you optimize a route for your group of friends through this thing. We had 70 teams this year, very small contest. Last year was probably about half that. And like I said, it's only been around for the 2 years. High school, been around for a little longer. We had 900 teams, one of our biggest ones this year. A 13-day window, same window as the other contest, actually, same time frame. Same thing though, we're working, the idea is they would work on it for a few days and then do their submission. Once again, so in this case, they'll see 2 problems. They can look at both problems, and then they pick the one they want to do, and that's what they would write up. So we've had them in the past. This year we had one on bees, the growth of bees in a hive, and how many hives you would need sort of to pollinate a certain size field. And the second one was about CO2 in the air and its relationship with sea temperature rise on the planet and things like that. So that's kind of what we had for the high school one. And the IMMC, really, this is really just like the Olympics, where after the one you just saw, the high school version, we then take the top teams from each country, and they're invited to a second competition. So in the US, if they decide to participate, we'll find the top 2 through a triage, and then they will go compete with other countries to figure out. It's a different problem over 5. It says 5-day period, but it's a 2-month period window where the intent is they would work about 5 days on it. And like I said, 1 or 2 teams per region. And here's the big one. So this is the by far, you can see the numbers there. Last year we had about 28,000 teams total, each team with 3 students. So, that's 70, 80,000 students from 22 countries and regions. Similar format though, they would log in. Now they're going to see 6 problems, and they'll pick from the 6 of the one that they would like to do. And then they work on that over a 4-day finite window. And this year, this is coming up. This is actually next week. And but same thing, we had them in the past. A lot of environmental problems. There's 6 specific categories for this one with ops research. There is a discrete math, continuous math, and a policy problem. So they're not all the ICM, which is 3 of the problems, the interdisciplinary, where M is the mathematical context and modeling. Little more of the social sciences sometimes, and both our judges for these different things, sort of that's where they would have their expertise. And by far, like I said, this is this undergrad or lower, meaning we've had a few high school teams will compete in this, but this is sort of the big contest that COMAP runs now. Like I said, here's the 6 different problems. So they register for the contest, they go in, they'll see all 6, and then they work on the one problem that they would like to do for that year. So what's successful? Well, we got to be able to read it. They have to be written in English. You have to answer all the questions, like any sort of thing. And obviously they do most of these things, and then we're looking for some of the top ones that follow. Just do all these things the best. And certainly citations and references and things like that. They can use code if they want to write code. and they typically submit it, but we don't check their code. But if they use their code to solve the problem, that's fine. Here's just the designations from left to right. So that we're looking, the outstanding is, we're talking out of 28,000 entries, that's like the top 10 or 12 literally become outstanding. The majority obviously are successful participants, and then sort of, from left to right or right to left, however you want to look at the different requirements there for the different types of things. Benefits to the students. So we think it does benefit, these students, obviously, and the next slide is going to talk about benefits to the advisors and so on, to the professors and teachers. But it's really helping, the problem solving skills is kind of key, just being able to write up something in a logical sequence that's readable. It's a nice blend of mathematics as well as prose, where they talk about what they did. We never like to see just a bunch of math equations, just a bunch of words. There should be some sort of mix and graphs and charts and so on, those types of things that we're looking for. And for the advisors, a lot of times they can use these in class to talk about them, mentoring, getting the students, just some opportunities to do other things for those students that would like to do this. And I am watching the clock here, Brian, but you can give me a warning if you want. I'm almost done here anyways. So basically for those two big, the MCM and ICM contests, we have lots of partners with other organizations that I'm sure you're familiar with that give sort of a separate award too. So like for, the SIAM award. So one of the papers, along with probably being one of the top papers, will also get the SIAM award, like a certificate from SIAM and so on. And we just started this thing with internships, really just started, where for some of the top, we were thinking about doing this. And before we could do anything, an organization, a venture capital firm in the US, Googled, math contest, found COMAP and said, hey, send us a list of all your top teams. We might want to talk to them. So we didn't do that, but we did work with them to sort of provide, we reached out to our top US teams and said, hey, here's an opportunity for a possible internship. Here's this company, go to their website. And like I said, that is just happening right now. And we do give out a little money, some scholarship awards, but it's mostly, certificates for the folks that play. Here's that new certificate in modeling that I just talked about. This is in progress. Sort of a one core, sort of intro to modeling, and then there'd be one for the educators on the left side, and then one more, the A course for the analysts, industry side. Like I said, those are just being developed now. More to follow on these, other than this is, I think Chris Ani was the brainchild at the start of this, and we got a bunch of folks sort of trying to come up with these modules for this certification process. And then what can you do? Well, the biggest thing for probably this audience is encourage your schools and teams to participate in one or more of these contests. If you'd like, you could be an advisor. You can be a triage judge. So if you go to that website, which is literally just the phone number of a CONAP, but you can sign up and say, hey, I want to be a triage judge, and they'll, we'll most likely, depending on how many we get, you could triage some of these things, and you're paid for your triage time. Search around the website see if there's any stuff there that you would like. You could join COMAP, and then all those social things, we're on all of those. And the website's pretty simple. It's just comap.com. And without very little time to spare, thanks for listening. Thanks for Brian Winkle for letting us participate. And are there any comments or questions? And I'm going to stop sharing.
Thank you, Jack. Any comments or questions? Feel free to speak up. I will tell you that it is very rewarding to work with COMAP and to work with the modeling competitions. I've worked with the undergraduate ones. I've not done the high school ones, but can you imagine what it would be in 6th grade if someone had touched you with that, given where you are now, how much further you might have been in terms of your passion for mathematics and using it. And each school develops its own culture. When I was at West Point, there was a whole cadre of kids who would speak to the underclassmen, the juniors, who would say, you really got to do this and so forth. West Point had a different advantage in that you got leave for the weekend. So you didn't have to be back for, into the barracks, and they hung out in office space we provided them. And Jack pointed out that many coaches, their whole job is to open the door, throw in a pizza every once in a while and shut the door, and just be there if they need something, but not to intervene with technical details. The kinds of, and Jack will know this best in terms of the triaging, the kinds of writing that you can get from some of these undergraduates is really remarkable. In fact, many of their results are published in academic journals. I think that was the other thing that is a reward for them. So the competitions, while not the only thing COMAP does, it is, as Jack pointed out, 28,000 people. Think of that, all doing mathematics in a period of time. So,
Yeah, 28,000 teams of three.
teams of three, yeah. We got to multiply by three, you know. Any other questions, any experiences you'd like to share and do an altar call here for this? No? Okay. Well, I want to encourage you to look up COMAP stuff and consider working with young people, consider volunteering your time as a coach, referee, and a judge. And well, thank you again, Jack, and we wish you well in your work.